Hello everyone, today's topic is symmetric key. So in this video we will be learning about symmetric key. Now what is its agenda or what is its base? So basically symmetric key is a part of cryptography. Now what is cryptography? So when we send a message from sender to receiver, so whether it is safe or not. So by using cryptography we can ensure that it is safe. So there are keys by which we can encrypt or decrypt the message. So what is the goal of cryptography? It is confidentiality. Now, there are keys from which messages are encrypted and decrypted. So, what are the two main types of cryptographic keys? It is symmetric and asymmetric key. Now, let's talk about symmetric key. So, symmetric key is also known as secret key or private key. Now, in this, the catch is the sender and receiver should have the same key. Now, when the sender is sending a message through the to the receiver through the internet, so basically it is an unsecure passage. So, symmetric key algorithms are used for encryption as well as decryptions. Now let us see what are the algorithms which are used for the encryption and decryption method. So first is the data encryption standard DES, then triple data encryption standard, and then comes the advanced encryption standard. So basically advanced encryption standard have different version. Minimum bit is used as 128 and maximum can go up to 256 bits. Now let us have a look at how it works. So basically when we have a message M and message is going to the receiver. So when message is going, so it will be encrypted by the key K, which we will use as symmetric key, and then the message will be converted into ciphertext. Now what is ciphertext? Ciphertext will be C is equal to encrypted, the key will be the encrypted EK. Okay, now then the message is encrypted with the key K and converted into ciphertext. This is the encryption. Now when it have reached the receiver, so what we will do, we will be doing the decryption there. So when the ciphertext have reached the receiver, what they will do, they will decode the same message with the same key. Here in symmetric key, as I told, we use the same key. So from that same key we will be decrypting that message, and that message will be securely traveled or securely reached to the receiver. Now here is the P is equal to DK, the decryption of key DK and the encryption of EKP. Okay. Now let us have a look on example for the substitution ciphers. Now here we have a plain text, which is computer network is the key to all problems. Now converting it into ciphertext. Here we switch the letters by two, like a C becomes E, O becomes Q, M becomes O. So for C I leave D and I take E, so I am shifting the letter right by 2. Here the key is 2, the symmetric key is 2. Now, while encoding and decoding, we will be using the same key too, but it is easy to break due to the frequency of the letter. Now, what is a good encryption algorithm? A good encryption algorithm is which it produces the output which looks like random bits, which takes random bits, and it is uneasy to explore what is the real message and uneasy to decode it. That is known as good algorithm. So let us talk about DES data encryption standard algorithm. So it was adopted in 1977 by NIST. Its input have 64-bit plain text and output as well as have 64-bit ciphertext. So what are the problems encountered? The problems encountered are it is susceptible to brute force, since you can try all 2 to the power 56 keys. Now the advanced form of DES is triple DES. Here we have to do it thrice with 3 different keys which related to the slower of encryption and decryption. So its key size is 168 bit, 112 bit and 56 bits. The most advanced is AES, Advanced Encryption Standard. Basically it was invented by 2 Belgian cryptographers. It was selected by NIST among 15 competitors. The selection criteria was security, cost, which is speed and memory. The implementation consideration were hardware and software. The key size and block size are 128, 192 and 256 bits. Thank you.